Today we're looking at evaluating inverse trig functions. Before we get into that though, we need to review a few things. And let's start with inverse functions. What do we remember about inverse functions? X and Y are switched. What else?
It doesn't have to pass the vertical line test.
It's got to pass what?
The vertical line test.
It's got to pass the horizontal line test. In order for a function to have an inverse, it's got to pass the horizontal line test. Alright, the inverse, if it passes the horizontal line, that means the inverse will pass the vertical. Okay, and what goes along with switching the x and y? What do we usually say the x values are? What's a word for x values? Domain. And what's a word for y values?
Range.
So what does that mean happens to the domain and range? They're switched. Okay? So we have that. We also need to remember some of our special angles. So write these 9 things down that I'm getting ready to put on the board because we need to have them readily available when we do these types of problems. Okay.
I know. Let's go.
I lost my
Get Mike's in the
connection
water.
to the smart board.
Yeah.
She's your little sidekick.
Wow.
There.
All right, so these nine special angles we need to have down in front of us. All right, so we need to know these 9 to be able to do what we want to do today with the inverse trig function stuff. So what is sine of pi over 6? What is pi over 6? Which angle is pi over 6? 30. What is sine of 30? See, this is taking too long. We should know what sine of 30 is. Sine of 30 is 1/2. Okay, if that's 1/2, what does that mean cosine is? Square root of 3 over 2. Okay, what about tangent? 1 over the square root of 3. So pi over 3 is 60. What's sine of 60? It has to be the square root of 3 over 2. Cosine? 1/2. Tangent? Square root of 3. Sine of pi over 4? 1 over the square root of 2. Cosine? 1 over the square root of 2. And tangent? 1. So we need to have these values in front of you. You need to be able to reproduce those values in a hurry if you do not have them just straight up memorized. Okay? You need to be able to reproduce those very quickly, okay, and use them. Now, these 3 right here, you will also see in a different form. Does anybody know another way that 1 over square root of 3 might look? If you go back to your algebra 2 days. What's something we might want to do to 1 over the square root of 3? Yeah, I want to rationalize it. So I want to move the radical. What would I do to move the radical? Multiply by the square root of 3. So multiply by the square root of 3 over 3. That's going to give me the square root of 3 in the numerator. What's it give me in the denominator?
3.
Just 3. So 1 over the square root of 3, square root of 3 over 3 are the same number. So sometimes when you're doing inverse trig, you might see that square root of 3 over 3. So I just want to make sure of that. So what does that mean you might see on this 1 over the square root of 2? Square root of 2 over 2. So square root of 2 over 2 is what you might see instead of 1 over the square root of 2. So whenever we're doing inverse trig stuff, we need to have this stuff in front of us. You either need to have it memorized or you need to have it in front of you. Okay? Because if you have it in front of you, that makes the inverse trig problems very snappy. If you have to sit there and think about it all day long, it'll take forever. So you either need to have that memorized or in front of you. But you need to be able to reproduce that on your own. Especially when it gets to test time. You need to be able to reproduce that on your own. All right, now we've done enough of the back work. We need to move on and look at the inverse trig functions. We're going to look at mainly inverse sine and cosine today. We'll get to inverse tangent tomorrow, and then we'll do some work on it tomorrow. So what do you think something I want to do if I'm interested in the inverse of sine?
Make it cotangent.
Say it again.
Make it cotangent.
Now go back to our chats a while ago when we were talking about inverse functions in general. Okay, the x and y's need to switch. So what's something I might want to look at that's going to help me consider the x and y's? And what's going to help me figure out what the range and domain are? Without a calculator. What are you usually looking at if I'm asking you to find domain and range?
Graph.
The graph. So the first thing I want to do is get a quick general graph of sine. And again, I'm going to put a lot of stuff up here. You don't have to write everything I'm writing down. I'll tell you when you need to write something down. So this graph up here, you do not have to write down. All right, so sine, we know, is going to start here. It's going to go out to 2 pi. That's where it ends. We know pi is in the middle. We know pi over 2 is right here. And it's going to be up here at 1. And we know over here is 3 pi over 2. It's going to be down here at -1. We know it continues on this direction. And I'm here at -1. We're back here at -5. So the general shape of sine looks like this. So if I'm interested in finding the inverse of sine, what's the problem? It does not pass the horizontal line test. Okay? But I want an inverse sine function. So what can I do if it doesn't pass the horizontal line test to work with something that will pass the horizontal line test? And we kind of did it back when we were doing inverse functions earlier this year. You're on? Right. We want to make it to where it passes the horizontal line test. Now, cut it in half is not the right terminology, but she's thinking correctly. Okay? So instead of cut it in half, what is it we want to do to the function? Starts with an R. Restrict it. Okay? We want to restrict the x value. We want to pick out a window. We want to pick out a window that gives me all the y values and passes the horizontal line test. So if somebody pick out a window from one x to another x that gives me all the y values and it passes the horizontal line test. Pi over 2 to 3 pi over 2 will work. That's not the section we want to use, but it does work. There's a certain section we want to use. Does anybody see another section that passes? Use the one that has the origin in it, yes. So what would that be? Very good. So the section we want to use is this section right here. Okay, so if I'm looking at just that section, I have all of my y values and it passes the horizontal line test. So that means we want to restrict our domain. You still don't have to write anything down yet. From negative pi over 2 to pi over 2. I'm going to restrict the domain to that. Okay, along with that, what are my range values? -1 to 1. Very good. The bottom is -1, the top is 1, so that means my range has to go from -1 to 1. So now that I have that, I can now start thinking about the inverse sine. And what do I already know about the inverse sine function? Or should I know now? It will pass the horizontal line test. It would also pass the vertical line test. What else do I know about it? Exactly. So I know that my domain, what is my domain? -1 to 1, and I know my range is what? Negative pi over 2 to pi over 2. Okay? Write that down over there in that corner. That inverse sine, write down the domain, and write down the range. Alright, so along with that, it's also very helpful to look at the graph of the inverse sine function. So we want to do that as well. What values need to be on my x-axis if I'm looking at the graph of the inverse sine? -1 to 1, okay? Because it says my domain is -1 to 1, which are my x values. So that means I need -1 and I need 1. What values need to be on the y-axis of my inverse sine function? Negative pi over 2 to pi over 2. So I need negative pi over 2 to pi over 2. Alright, then how am I going to use the original function of sine to graph the inverse sine? What are we going to do? Kind of, yes. I'm going to pick a point, and what am I going to do to the point? What'd you say, Bree? I'm going to switch the y and the x value. Very good, Bree. Alright, so let's take this first point right here on the left. What is the ordered pair of that point? Negative pi over 2, -1. Negative pi over 2, -1 is that first point. So my first point over there on my inverse sine function needs to be what? -1, negative pi over 2. So -1, negative pi over 2 puts me there. Alright. The next point I want to pick out is this one right there in the middle. And that's easy because what is that point? 0, 0, 0. So what happens when I flip it? I still get 0, 0. Alright. Then the other point I want to pick out is right here. And what's the ordered pair of that point? Pi over 2, 1. So over there it's going to be 1 and pi over 2. Okay? Does it make sense that those three dots are pretty close to where they were? Why?
Because you're not changing anything.
Well, I am, but how is the graph of a function related to its inverse? What has to happen? How are they related? Besides switching the x and y. Because they are flipped over something. There we go. It's switched over the y equals x. So the y equals x line is right down the middle. So if I'm doing it right down the middle and I flip it, you know, it looks like they're right back on where they were. So that's why there's not much change. Okay? But now the curves are going to be different. This curve right here looks like this. So when I go to that piece over there, what should it look like? It should be curved the other way. So it should be curved like that. Because I had to flip it over the line y equals x. This one is like this. So on the other side it needs to be underneath. Alright, now, next thing you need to have on your notes is you need to have that graph of inverse sine. So draw that graph. You need to have that in front of you. Okay, so far we need our 9 special angles in front of us. We need the domain and range for inverse sine, and we need the graph of inverse sine. Okay, we're getting ready to use that on our next step. So before we evaluate an inverse sine function, I want to go back and evaluate a regular sine function. Okay, so let's say I wanted to know what is y equals sine of pi over 3. I want to evaluate sine of pi over 3. So what am I going to do to go about evaluating sine of pi over 3? I know that it is the square root of 3 over 2. Now, how'd you get the square root of 3 over 2, Bailey? You went to the special angles, and you should have matched those two up and figured out what does the combination of those two produce. And it gives me the square root of 3 over 2. Okay? Now, I want you to notice something. On a regular trig function, what is it that we are inputting? What is pi over 3? What does it represent? What did you say, Bobby? It represents an angle. Okay, so if I'm dealing with a regular trig function, we are putting an angle into it. And we are getting a number out. So that means if I'm going to do an inverse trig function, what is it we're putting in?
Number.
A number, and what is it we're getting out?
Angle.
An angle. That is very important. If you are evaluating an inverse trig function, what should you get as an answer? You should get an angle as an answer. That is very important. So, an inverse trig function that we want to evaluate looks like y equals inverse sine of the square root of 3 over 2. Okay, notice what is being inputted? A number, so that means what do I need to get out? An angle. Now, what are we going to do to find that angle? You're going to use your special angles chart. What are we going to look for? We're going to look for sine, and we're going to look for square root of 3 over 2, and we're going to figure out what angle matches those two. So what angle matches it? Pi over 3. So my answer would be pi over 3. Okay, let's try another one. I have y equals inverse sine of the square root of 2 over 2. So what do I want to do? Look for the square root of 2 over 2 and look for sine and figure out what angle do they match at. So where do they match? Pi over 4. So my answer is pi over 4. Okay, what about this one? And here's another way you might see an inverse function. Instead of sine to the negative 1, they might show it as arc sine. Okay, arc sine and sine to the negative 1 mean the same thing. We're still talking about the inverse of sine. So I want to know y equals arc sine of negative 1. What's the issue this time? Is there a 1 on your special angles for sine? No. So what does that tell me? It's not a special angle. If it's not a special angle, what type of angle is it going to be? Quadrantal. Okay? So if it is not on your special angles, that is where you want to go to your graph. Your graph will help you figure it out. So what do I need to go to the graph and look for?
-1.
The x value of negative 1. So the x value of negative 1 is right here. And what do I want to look for? The y value that matches it. So what y value matches the x value of negative 1? Negative pi over 2. So my answer would be negative pi over 2. Say it again. On sine, yes. On inverse sine, negative 1 will always give me negative pi over 2. Is that what you're asking? Yes. Okay. What if I had y equals arc sine of, let's see in there, arc sine of 0? I want to find arc sine of 0. Do I have a 0 on my special angles?
No.
No. So that means I need to go to my graph. What y value does the x value of 0 give me? It gives me 0. So we end up with 0. Okay? Everybody okay with it so far? Alright. Yes, Bruce.
If you use R sign like that, is it always going to be a quadrantal angle, or
No.
does it matter?
It just happens to be that way. Good question. Alright, now I have y equals arc sine of negative 1/2. Do I have a match for negative 1/2? Or do I have a match for 1/2? Let's start with that.
Yeah.
What's my match for 1/2? 5/6. Okay, but I need to deal with that negative. What does the range say my answer has to be between? Negative pi over 2 and pi over 2. Okay? So this is another place where my graph is going to be helpful. What part of the graph will you find the x value of negative 1/2? Which side? On the left side. Negative 1/2 is going to be over there, correct? Okay, so I'm looking for the y value that matches up with it. Okay, and we already know it's going to be some form of pi over 6. We just need to know what form of it is. Okay, so here's the deal. If this is pi over 2, what would be halfway between, or if this is negative pi over 2, what would be halfway between these two? Pi over 4. So halfway would be negative pi over 4. Okay, what comes just before negative pi over 4? Pi over 6. So right here is going to be negative pi over 6. Okay, so what does my answer need to be instead of pi over 6? It needs to be negative pi over 6. Okay, now, yes,
But pi over 6 isn't that halfway.
you're correct. I didn't go halfway. My dot right here is a little bit above halfway. Okay, and that matches up with my negative pi over 6. Okay, now answer me this. Anytime this number right here is negative, what is my answer going to be? Why? Because my graph over here is only negative right here, and all of those y values are what? All those y values are negative. So if I'm dealing with inverse sine, and I'm dealing with a negative number, I know my answer has to be negative. Okay, let's try one more with inverse sine, and then we're going to move to cosine. So let's do y equals arc sine of negative, let's do square root of 2 over 2. So I want y equals arc sine of negative square root of 2 over 2. So I want to find my match. What's my match between sine and square root of 2 over 2? Pi over 4. And since it's negative and I'm dealing with arc sine, what does my answer have to be? Negative. And I have successfully evaluated arc sine of negative square root of 2 over 2. Questions on inverse sine? Now that we've built that up, it should be pretty easy to go through cosine. What do you think we need to do to get started with cosine?
Graph it.
Graph cosine. Very good. So I need to graph cosine. And again, you don't have to do this just yet. I'll let you know. Alright, this is what cosine looks like, and it goes on and on and on. And as it sits right now, what can you say about it? It doesn't have an inverse, because it fails what? The horizontal line test. But I want it to have an inverse, so what am I going to do?
Restrict.
I'm going to restrict it. So Lauren, give me x values that you would recommend restricting this for.
0 to pi.
0 to pi is perfect. Very nice. So I want to restrict this thing from 0. I want to restrict it from 0 to pi. Everybody understand why I want 0 to pi?
Yes.
Okay, it gives me all of my y values, and that section passes the horizontal line test. So, for regular cosine, what is the domain? What did we just say?
0
0 to pi. What about my range? -1 to 1. So now we're ready for inverse cosine. This is what you want to write down. So what is my domain going to be for inverse cosine? -1 to 1. Okay, and what's my range going to be? 0 to pi. So there's my domain and range for inverse cosine. Okay, what do we do when we're dealing with inverse sine after we found the domain and range of it? We graph it. We want to graph it. So what x values do I need to have for my inverse cosine function? -1 to 1. Because my domain is -1 to 1. So my x values still need to be -1 to 1. What do my y values need to be? 0 to pi. So I want to be 0 to pi. So that would be pi. Let's go ahead and put pi over 2 in there. So now we're ready to graph. What do we want to do to be able to graph it? Find the original ordered pair. So let's use this first one up here at the top. What's the ordered pair of that first one? 0, 1, right? And then 0, 1. So what does the other one need to be? 1, 0. The other one needs to be 1, 0. Okay, the next dot I want is right here. What's that ordered pair? Pi over 2 and 0. So over there it needs to be 0 and pi over 2. So 0 and pi over 2 puts me there. And the last one, pi and -1. So over there it needs to be -1 and pi. I'm going to move this over a little bit. Right? So there are my 3 dots. Now I need to figure out what the curves look like. So what am I going to do to help me figure out the curves and connecting those dots?
Look at that one and just
Look at this one and rotate it. So right here, if I take this piece, if I take this piece right here, what's going to happen when I rotate it? It's going to look the same, isn't it? So if I take that piece and I flip it, it's going to look the same. So right here, this piece is still going to be curved like that. This other piece, right here, when I flip it and go all the way over, so how do I need to connect those two? It needs to be curved the other direction. So it's going to look like that. So you need to have the domain and range for inverse cosine written down, and you need to have the graph of inverse cosine written down. Okay, you need to have that available to you. Bailey? Yeah, confused look on your face.
Yeah, how do you know when they're gonna switch or not? Like with the curves. You know, it's like
Well, remember, my line is right there, so I want to know if I flip it over that line, what's it going to look like? And this piece right here, if I flip it, it's going to be right back on top of itself.
So you flip the separate pieces?
Well, I'm just looking at each curve separately, and that'll help me instead of looking at all of it. So if I take this and move it all the way up here,
Gotcha, okay.
okay, if I do that, then it's still going to have the same kind of shape.
Oh, I got it now.
All right, so that's what we need. Now we're ready to evaluate inverse cosine like we did sine. So y equals inverse cosine of, let's start with the square root of 3 over 2. Pi over 6 is correct. How'd you get that, AJ? Say again. Special angles, I look for the match of cosine and radical 3 over 2. That produced pi over 6. Any issues with that? Okay. I have y equals inverse cosine of -1.
So you have to refer to the
Pi.
I've got to refer to the graph, and Blake says pi. Okay, Blake, why'd you choose pi?
Because on the graph, -1 corresponds with pi.
Okay, on the graph, -1 is right here, which corresponds to the y value of pi. So that's why we choose pi. Okay. So far, very similar to sine. Now let's do one that's different than sine. Okay, I have y equals arc cosine of -1/2. So just like sine, we want to find a match. What's my match for cosine 1/2? Pi over 3. But now I need to figure out how to handle the negative when I'm dealing with inverse cosine. What did we do with sine whenever we had a negative? We just made our answer negative. Okay? Will that work for cosine?
Probably not.
Probably not, but I want to know why not.
Because all of our little sections.
There are no negative y values. What tells me there should be no negative y values besides the graph? The range. My range says it has to be between 0 and pi. There are no negative values between 0 and pi. So let's look at my graph to help me figure out what I need to do. So -1/2. -1/2 is somewhere in here, correct? So that means I need to go up and find that point, which is somewhere up there. So let's do what we did on the last one. This is pi, and this is pi over 2. So what's halfway going to be again? It's going to be some form of pi over 4, but what form of pi over 4 is it going to be? 3 pi over 4. Rachel, how'd you get 3 pi over 4? You guessed. Somebody give me something besides I guess. How do we know it was 3 pi over 4?
Closer to pi instead of closer to 0 as it would be in the denominator.
All right, build off of that.
What about the cosine?
I
I was thinking about whenever it was pi over 4, pi over
less
2.
than pi over 2, and you're going above pi over 2.
Okay. But how do I know it's going to be 3? How do we choose the number 3?
Because you told us.
Probably said it.
3 comes before 4.
What quadrant is between pi over 2 and pi?
2.
2. If I go to the unit circle, what quadrant is between pi over 2 and pi? Quadrant 2. What was the trick to put an angle in quadrant 2? The numerator was 1 less than the denominator.
Oh, yeah.
Okay? So that's how we know it should be 3 pi over 4. Okay? So I know this has to be pi over 3. So this right here has to be some form of pi over 3. And what form of pi over 3 does it need to be? It needs to be 2 pi over 3. So my final answer over here needs to be 2 pi over 3. So, if I'm dealing with inverse cosine and I have a negative number, what do I need to do to my answer?
Just put
Use the
1
graph.
less.
I need to make the numerator 1 less than the denominator. That's if I'm dealing with inverse cosine. What happened when I was dealing with inverse sine?
You just made it
We
negative.
just make it negative. So you've got to keep those two things straight. Okay? And what causes me to do one way and one the other way? The graph does, and more specifically, the range of each of them. That causes me to do them differently. Very good. Okay? So that's why I have to do those differently. Okay? So, we've got to make sure whenever we do these, we need to have this information for inverse cosine in front of us. We need to have that information for inverse sine in front of us, and we need to have the 9 special angles. You're going to, when you get to the test, you're going to have to be able to either have that all memorized upstairs, or you're going to have to be able to reproduce it and use it once you've reproduced it. Okay? It's not that hard to reproduce, and we'll probably practice reproducing it. Okay? But I've got to be able to produce that so that I can use it. Because once I have all that, once I have all that to be able to use, these problems are pretty easy. Hopefully you'll see that. All right, we will stop there. Tomorrow we'll look at inverse tangent, and then we will get into working some problems like this.